Hello, today we are going to talk about finding the sum of a given geometric series. So we're going to start right away with the formula for the sum of a geometric series. So this is one of the things, once we get all the parts labeled, you want to copy this down. Maybe you want to pause the video right now and write this in your notes. But the things we have, so this right here, hopefully we know, this means the sum of the first n terms. Usually we know that our A1, this is the first term, so that's the first number that's in our series. The R in both cases means this is our, actually I can put these together. This is our common ratio. And the N right here, oops, this is the number of terms we are adding. There's a really cool Khan Academy video. We usually do this in class, but this year we're not going to. But if you want to see where this formula comes from, you can watch that video. It's kind of a cool little proof or derivation. Otherwise, you just have to, for this year, you have to know how to use this formula. So let's practice doing some problems. Okay, so I want to find the sum of the first 10 terms of the series. So your first thing is we have to figure out, is this arithmetic or geometric or a neither? Because then there's different ways. If it's a neither, we basically have to do brute force and just find all the terms and add them up. So I'm looking at this, and I always look at arithmetic first. If I added 50 and I added 50 again, that would not get me to here. So not arithmetic. So then I'm like, is this geometric? Well, and if I want to find my ratio, I can always take a term and divide by the term before. 150 divided by 100 is 1.5 or 3 halves. And if I do 225 and divide by 150, I should also get 3 halves, because this is 2 times 75 and 225 is 3 times 75. And I could keep going and check to make sure they all are, but I'm pretty confident that this is my R. Okay, so I need to fill in this formula. So I want the sum of the first 10 terms. It should look like a 10, not a 16. And I'm going to take my first term and I'm going to multiply by 1 minus my common ratio. Oops, that's 3 halves. That looks really bad. Let's try that. Let's fix that a little bit. The one thing I'm going to say, and then I need to know how many terms. Well, we've said 10 terms, so this is to the 10th power all over 1 minus 3 halves. You need to be really careful, because if I write this, and it looks like this, what this problem says to me is that I raised 3 to the 10th, but not the 2. So I want all of that to be raised to the 10th power. The other thing to pay attention to is the fact that this n to the nth power is inside my parentheses. If we go back and look at the formula, this n is right here. Then we take that whole number and divide by this, right? So we have to be careful when we do this. So now we're going to try and type this in our calculator. The other thing when you're going in your calculator that I want you to watch out for is we also are going to need parentheses around the bottom, because I want that to be one number. So if I pull up my calculator, and I can do this, so I'm going to take 100 and I'm going to multiply by parentheses 1 minus, again parentheses, 3 divided by 2 to the 10th power. I want that 3 halves to the 10th. And then I am going to end the top parentheses, and I'm going to divide by my bottom, which is 1 minus. And just to be safe, whenever you're working with fractions, it's generally a good idea to put that fraction in parentheses. Now, the TI doesn't care if I close my end parentheses or not, but let's just do it because it looks more complete, and some programs will require you to do that. And now I click enter, and there is my answer. One cool thing you can do is if you want to see if this is a nice fraction, you can hit the math fraction button. And this one does not have a nice fraction. So we will just, let's shrink that down. So 113, actually, I think I can pull this over right here. And there's my answer. This is my answer right here. That's my answer of the sum of the first 10 terms. Okay. We can try another one. So again, the first thing is trying to figure out, is this arithmetic, geometric, what's going on? And from the first to the second is not super easy. It looks like I divided the top by 2. But sometimes it helps to look beyond the first terms. Going from here to here, it looks like my bottom got multiplied by 2, and my top did not change. And then if I go here to here, my bottom got multiplied by 2, and my top did not change, multiplied by 1. Would that have worked going backwards? If I think about taking 2/3 and multiply by 1/2, what does happen is I get 1/3, and that checks. So I think that tells me that my ratio is 1/2. Multiply the top by 1, multiply the bottom by 2. Okay, so now I can plug this in to my formula. I want the sum of the first 8 terms this time. So the sum of the first 8 terms is, again, I take my first term and I'm going to multiply by 1 minus 1/2 to the 8th all over 1 minus 1/2. And again, you can pause the video and try and calculate that yourself and see how you do. So hopefully you came up with an answer. I came up with this, 1.32, and it says round to the nearest thousandth. So it's 8/1, so I'm going to have 1.328. That's my answer, the sum to the nearest however many. Okay. All right. So now we can have a problem sort of like this, and this is a little trickier because I want to fill in all my parts, but some parts are missing. So I think I'm going to leave this actually for a second video. So I'm going to stop this one here to make it short, and then we're going to create a second video for the next 2 problems.